Hello. Okay, we got an update, which is, well, that can't be good. Wonder why it's doing that. Oh, went away. That was the blue screen of death lurking around the corner. Okay. No, I had just shut my computer down. Really? Not very long ago. Okay. Okay, while that's loading, I'll go to recent. Recent is, ooh, yeah. Okay, lots of changes, lots of stuff. And I got, let's see if that started yet. It's still trying to start. Um, so, go ahead. So this basically has seven patches. One is for backspace, completely working. Poking is completely working. Printing is completely working. Set X, Y color, completely working. CLS is completely working, and after carriage return return is working actually. And then scroll screen by one line is not done yet, incomplete. It's connected to the ROM, but not implemented. Yeah. So those are all the patches to the ROM, and let's see. This checks to see if basic is moved and performs a new test to make it continue after new. So anyway, okay, it started. Now there's one small problem. Is that my patch is fine, but the code broke back here at 7, I think. So I've got 1, 2, 3 updates that wouldn't work if it wasn't for a certain way that I do it. Like, so we load this to 0 because it's just a chunk of 64K, and that loads it in running. Well, not running, but loaded. And then later I can save that as a cloadm file. Then I have to actively load the other program before I run that. That's loaded at 20805. We browse. Okay, now I can't load this one because it doesn't load properly. I have to load the set one from back then, and then I can execute 28125, which is the location of ROM 1.3, and then I type EXEC 20805, and then lo and behold, it says Microcolor Basic 1.3, copyright 1982, Microsoft. Everything looks fine. Okay, but it's still running. If I do CLS, you can see it's still taking time to do the CLS, right? So what I'll do is I will load over this with one of my other versions. This shouldn't be very hard to fix, but I don't want to say. I don't want to guess. Okay, so now if I say, let's see, whoops, there's nothing in there. But if I do list, now you know, it's a funny thing I noticed that if I forgot to type new, it didn't really matter, because unless you're going to type a program, if you're going to type a program, it'll probably go crazy. So if you print memory before you've done of new, it'll show 7,751. Well, that's what you normally have. So without that memory right there, basically you have 4,000 something. I mean, you really have 4,000 something. Okay, so my point being, when you load something like this, it performs a new, and it actually initializes the memory properly, so you don't have to type new if you're going to load a program. That's it. And then if I can find, I'll just load this one, Hangman. It loads, and then if I list it, now watch this, don't miss this, watch closely, bam. And see, the last implemented patch is the line scrolling right there at the bottom. Scroll the line by one line, and that's not done yet. I have written the code, but it's not implemented in this version. It's implemented in an earlier version where I thought it wasn't working. It actually, well, it was getting confused, and I figured that out finally. So I implemented, like I said, I implemented print at, actually print is tied with print at, and I implemented printing, carriage return, what happens after carriage return, CLS, backspacing, set XYC, and poke address value. Yeah, that works. And just thinking about that. Okay, so then we'll take alarm going off. Okay, so then now that I've got that listed, and it the update didn't occur here to update it to the, or did it? Let me see. CLS. Now notice that the CLS cleared the screen right away. And then list. Oh, it starts at 100. Yeah. So the screen didn't update because my program that I wrote a long time ago updates the screen all the way from the 512th position on the screen all the way down to the 1 position, or say 511 all the way to 0. And anybody who's used print at would know that the position all the way down to the far right of the screen is actually print at 511. That E on the end of the rice, So now that is said and done, we'll go CL. Well, first I'll run it for you, just for a little bit. Ooh, it's really loud. I'll turn that down a little bit. Okay, maybe down a little more. Okay, and usually the first one is, I know the first one, not always. And then I'll do one more for you. See, the screen is running full speed now, basically. Okay, so now just say no. I don't know if it's in there or not. I'll type new. I don't need to, I guess. Okay, C load, and I was going to load play cassette, load Tandy's, microgames, horse. Okay, run. There they go. Okay, pretty cool, huh? Anyway, small update. Huge update as far as progress, but just a couple videos. And okay, poke. You want more horses? 20811, comma 125 124, I think it is. Run. Wow, that one's really going, huh? Number 1. And it did win. So there you have it. A horse race in black and white. And that's a high resolution screen. It's 256 by 128 with a repeated bottom part of the screen. And looks better now that it's yeah, sound gets funny on the emulator sometimes. So anyway, more updates later. Oh, I can show you something else which is kind of fun. If you go 10 A, let's say for A equals 0 to 511, print at A, comma, quotes, and colon next A, and then we'll do a 5 CLS, and we'll run that. Oh, I forgot to put the space in. Okay, let's try the space. Oh, it has that other program in there still. Oops. New CLS 5 CLS 10 4A equals equals 0 to 511 colon print at A, comma, space, colon next A, run. There it goes. So that's on the high-res screen. It's printing pretty fast, and it's printing hello world, and I'm not sure what will happen when it hits the very end, because it's going to run out of space. It's still printing. No? Oh, it's done. the print erases the line, so it would normally be above that line, but it erases the line. I put it above, but we can't see it because my program didn't update because of the scroll line is not implemented yet. So everything else is implemented except for the cursor update. That's not there. Besides that, those are the only two things that I know of right now that aren't implemented, and my program is residing at pretty close to 3K. I think I've got a little more room and some ideas to save space and some ideas to change colors and some ideas to fix the fonts and because the fonts are, some of the fonts are broken on certain screen modes. Well, at least they display funny on certain screen modes. So I want this consistent font right here, the O and the K. It displays displays pretty good in any screen mode. Basically, if I poke, say, even 20811, comma, say 60 is not really a weird screen mode though. Oh, that's this one. Okay, poke 20811, comma 30, or maybe it's 40. I think it is 36. I think 36 works. It's a bigger, stretched out one compared to, say, like 20811, comma 40. It should be smaller. Oh, that's bigger. I'm wrong. 44. Poke 20811, comma 44. That's the smallest one, but it's also got a repeat on the bottom of the screen. So anyway, CLS, bam. So my updating implemented thing is turned off, and now it's just the computer doing it's kind of just spliced in and doing what it's supposed to do. I think it's pretty cool. I can't wait for an update I can actually release. I can't release this one yet, but and if we type new, it looks like we are going to have 4,279 bytes free. I thought it was different than that, but anyway, for now, that's what that is. And I thought I had a little more than that. Should find my notes. But it seems to be loading in programs quite nicely. Maybe I should reset that just to see. Let's see. Yeah, I'll do a hard reset. Just check. Load. Okay, 0. Browse. I gotta go back to 7. No, not yet, but I'm gonna go back here. They're all the same ROMs anyway. And then there. And then load the binary from the same place to here, 20805, open, and then execute 2812, not 6, 5, and execute 20805, type new, print, mem. Yeah, see, it's a little more. For some reason the other one was reserving something. Hope that wasn't a flaw. And so I'll browse, go back here. Probably the fact that I ran some programs that took some of the memory from one of those. This is the one I need. And okay, so now the other thing, yeah, it's implemented. Good. But now we'll type new, print mem. Yeah, it's 4,679. So your real memory is 4,679. And if it goes less than that from something you're running, or somebody moved memory, or one of the programs might have moved memory, or string memory might still be there, whatever the reason, that is your actual memory, 4,679 bytes. So what can you do with 4,679 bytes. Well, there is another advantage to this, is that you can also program your own fonts, which means that your fonts aren't limited anymore. So I'm going to try to come out with a utility eventually that's basically, for one, I'll give away the, I'll let people know what the memory locations of the fonts are after the version is completed, and I'm planning on moving the fonts to a location where they can be, probably what I'll do is I'll have a position in the my code that'll tell you where the fonts are, because if I don't do that, see, the fonts I can move if you use different screen locations, I can actually save memory and move basic to gain more memory on different screen modes up to the size of my font. So if my font is basically, my font is, to show you in the code here, if we go down, it starts at 0 and it goes all the way up to 175. Now, the reason why it doesn't go all the way up to 255 is because they're just repeated information for these screen modes. There's not enough colors to display all these things, and so when I go to, let's say, if you take 175 and you multiply by 6, that's the space it takes up. So it takes up 1050 bytes. Which is 6 times 175. Yeah, 1000. So, with that said, we can move, if I have a reporting thing that reports where memory is, and then, or not where memory is, but where fonts are located, because if I use I believe if I take out the highest resolution screens, that brings us down to, we gain 1000 bytes here, so that would be, or plus, just say print, oh, not on the right screen, print 4679, literally, plus, well, it would be about 1000. I might have to shave off a few fonts because I need it down to 1024. So 1024 would be 5703 bytes available, which isn't bad considering their program was only allowing 7,000 some bytes. So it's almost 6K, and so I think the other one was allowing about almost 8K or 7,700 something. And so then, and if you bring the screen down a little more, of course you can move more of the program over. In theory, I haven't done that yet, but it's possible to make also a specific program for various screen modes. And so far the 16 width screens are not implemented, and these are all 32-bit screens, and so far they're all available, which is actually 2 extra ones, which is so there's 10 screens. There's a total of 20 screens, and it also wouldn't be hard to implement the regular screen, so that'd be another 2 there. And then I do have some code for implementing the 16, but before I do that, of course, I gotta fix this problem that I'm dealing with right now. So anyway, of course, I want to get that cursor flashing. So figure out what's not doing that. Go take a look at the MC10 ROM file that's freely available. That's how this was made, including the the debugger here with the registry window, the memory window, the history window, the assembly window. You've got a method of finding everything about everything on this thing, and not to mention the ability to load a binary file to save machine language. Save what we do. Cload M's on. You can right here under. Anyway, there's just a lot you can do here. Yeah, save RAM. That's how I get the that file loaded actively, and edit it with a hex editor after that to patch it in. So that's it, and you can find information in a file like a fingerprint. I mean, it is very, very easy to do. So that's my update for today. I will see you next time.